We're still talking about our algebra review. We're going to stick with, just for this video, solving equations again. We're going to talk about different types of equations than we have so far. We talked about linear equations. We talked about quadratic equations. Now we're going to talk about some different types of equations. Here we have an equation that involves reciprocal terms. Anytime that you have your variable in the denominator, that's called a reciprocal function or a reciprocal term. So if we want to solve these equations, then we're going to have to isolate our variable on one side of the equal sign, but we need to realize that it's buried up in division to start with. So we have some fractions here that we have to deal with. We're going to have to get rid of those fractions. We're just going to have to step by step go through and isolate that variable on one side of the equal sign. So the first thing that we could do here is we could multiply. There's more than one way to do this. We could multiply both sides by x. That's going to get rid of this denominator. And then we could also multiply both sides by the other denominator, x minus 2. And that would help us get rid of that in the denominator. Again, this is a powerful mathematic term, so anything we do on one side, we better do the identical thing on the other side. That's just one technique that we could use. So if we were going to do this, I would multiply the numerator here, 3, by both of those terms. That would give me 3 times x plus 2 over x, correct? And in doing that, that gets rid of, remember that's multiplying by 1. You could say it cancels. So that simplifies. We could do the same thing here. I won't write this step down. I just want you to see what I'm doing. And that will give us the result of 5 times x, because the x plus 2 is going to have a value of 1, correct? And that will equal 2 times x plus 2. So what we have over here is we have 3. I'm going to distribute this 3x plus 6. Are we okay with that? Plus 5x equals, if I distribute this 2x, I'll write it so you can see what I'm doing here and so I don't make any mistakes. If I distribute this 2x over that parentheses, that gives me 2x squared plus 4x. Now, combining like terms, I have 8x's on the left side, 4x's on the right side, so I'm going to subtract 4x's from both sides. That's going to leave me 4x here. I still have a plus 6, and I have a 2x squared. So I want to, now I have a quadratic equation, and now I have lots of different ways to solve this quadratic equation. I'm going to put it in the proper form. 2x squared, I'm going to subtract 4x from both sides, and I'm going to subtract 6 from both sides, and that's going to leave me a 0. Now we can use the quadratic formula. All terms have a 2 in common. I could divide through by 2. I could use completing the square. I can use just straightforward factoring. This one's not difficult to factor to find my solution. So my coefficient to the x squared term is 1. So that's x times x. I need two numbers that when I add them I get negative 2, but when I multiply them I get negative 3. So that's a minus 3 and a plus 1. So either x minus 3 equals 0 or x plus 1 equals 0. So my solutions are x equal positive 3 or x equal negative 1. So I just multiplied through and got rid of those fractions, which is a good technique. There's nothing wrong with that technique. It's not the only one. I definitely could have found a common denominator to these and put them together and then cross multiplied over my equal sign. Lots of different ways to solve this, but it doesn't really matter which way that you do it. So we did definitely get the same answers that they did here, so our technique worked. Now, other types of functions that we're going to look at are ones that involve radicals. And when we have radicals, we're going to have to be careful when we square things. So you've got to be careful about, I want to get rid of this radical so that I can isolate the x that's buried underneath it. So when I see a radical in my expression, I know that I want to isolate that variable by itself, and in order to do that, I'm going to have to square that radical term. Well, if I square that radical term and get rid of it, I don't want anything else attached to it outside of the radical. So the very first thing that I would do is get this positive 1 over here on the left-hand side of things. So I would subtract 1 from both sides. That leaves me a negative radical 2 minus x on the right-hand side. I can take that whole thing and square it. I can also take that whole thing and square it. Not just adding, subtracting, multiplying, dividing, but as we go through mathematics, any mathematical operation that's done on one side of the equal sign will yield us an equal result if we perform the same mathematical operation on the other side. So since I want to square this side, as long as I square everything on this side, then I'm good. Now recognize that exponents don't break up over addition and subtraction. This is like saying I'm going to multiply 2x minus 1 times 2x minus 1, and that's a common error, so be careful with that. So let's clean this up. We're going to get 4x squared. Outside is minus 2x, inside is minus 2x, so that's minus 4x, and last is plus 1. And this simplifies really, really nicely. It's simply 2 minus x. Now the radical's gone. I don't have to deal with the radical anymore. So I'm going to gather like terms. I have a quadratic function. I'm going to use a good technique, whether it be the quadratic formula, completing the square, factoring, whatever, to try to get this solved. So let's see if I have enough room here. I have 4x squared. I'm going to add x to both sides, so that's going to leave 3x here. And I'm going to subtract 2 from both sides, so that's going to be a minus 1. This is probably a good candidate for the quadratic formula. So let's just try that. I'm going to squeeze it in here. We have negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So we have x equals 3 plus or minus the square root of 9 plus 16 is 25. That's pretty handy. All over 8. So we have 3 plus or minus 5 over 8. So we have x equals 3 plus 5 is 8. 8 over 8 is 1. 3 minus 5 is negative 2. Negative 2 over 8 is negative 1/4. So both of these types of equations simplified down for us into a quadratic equation, which we know how to solve. So that's pretty handy. So you can see that quadratic equations show up over and over and over and over. There's the answer to that one. So 1 1/4, that's definitely what we found as well. So it doesn't matter on our equations whether we have reciprocal terms, whether we have terms with roots in them. We still can use really, really good types of techniques to get them into a form where we know how to find those solutions. So one thing I want to say, especially when we're solving real-world equations, sometimes we get extraneous solutions. Let's say that for this last question, it had something to do with the number of wolves in a protected reserve. Well, this is a very good mathematical result. X equal negative 1/4 was a great mathematical result to the math that was in front of us. But in the context of answering a question concerning wolves in a reserve, I'm never going to have negative 1/4 of a wolf. So although I had a great mathematical result in the context of this question, that result is meaningless. We call that an extraneous solution. So just because your mathematics might be dead on, please don't forget the context in which you're working. And when they ask you a question with words, answer the question with words. We could say, if this was the result, there is 1 wolf in this preserve because we're not going to have negative 1/4 of a wolf. So make sure that context, especially when you're dealing with word problems, comes into play in your answer. So a really short video, 2 different types of equations. Come to class next time. We'll work some homework problems.